Good morning, welcome to Morning Maths, day 23. You need your pencil and paper. Let's get started. So, number 1 for year 3. Got all the work uncovered today. What is the value of the 7 in 729? What's the value of the 7 in 729? So we have units or ones, tens and hundreds. Oh, the 7 is in the hundreds column, so 700s. In digits, we could write 700. 700s is, of course, 700. That's question 1. On to question 2. If you're ready. This is plus. It says the word plus, which is, of course, add. 538 plus 429. 538 429, both 3-digit numbers. Copy them carefully. Let's check I copied them right. And add them. 8 plus 9 is 17. 1, 7. 3 plus 2 is 5. And a little one, 6. 5 plus 4 is 9. 967. Quick check. Pause if you need to. Make sure you copy everything down, and we're on to number 3. 320 take away, which is this sign, the minus sign. 320 take away 158. 0 take away 8 is not 8. 0 take away 8 is not 0. 0 take away 8 you can't do. If you've got no sweets, you can't give your friend 8. So you need to borrow. 2 goes down to a 1. We can borrow this 1 in the units column. 10 take away 8 is 2. Now we're stuck again because 1 take away 5 we can't do. 1 needs some help. 3 goes down to a 2. Borrowed a 1. 11 take away 5 is 6. 2 take away 1 is 1. 162. Minus makes things smaller. So 320, when we did the minus, it got smaller and it was 162. Let's go on to question 4. 4 times 5. 4 times 5. I'm going to do this with these lemons down here. 4 times 5. There are 4 lemons in a packet. 1, 2, 3, 4. You can see 4. 4 times 5 would be if you had this packet of lemons, but you had it 5 times. So you didn't have 1 packet of lemons, you had 2, 3, 4, 5. Because what you've got then is 4 lemons, but you've got it 1, 2, 3, 4, 5 times. That's what times is. 5 lots of the 4 lemons. What's the answer to that? Well, we could count all the lemons if we wanted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 4 times 5 is 20. Or you could sing your songs, because 4 times 5 is 4, 8, 12, 16, 20. So the answer is 20, whatever we do. 4 lemons in a pack, and you've got 5 packs, you would have 20 lemons. 4 times 5 is 20. So let me write down the question for number 4. 4 times 5. 4 times 5 is 20. And we're on to question 5. So question 5 is 9 divided by 3. 9 divided by 3. I'm going to do that with these footballs down here. I'm going to get 3 sacks. At school we keep footballs in big sacks, big bags. And we're going to do 9 divided by 3. So I'm going to share these footballs. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 of them. I'm going to share those 9 footballs into the 3 sacks. 1 for you, 1 for you, 1 for you. We all know division is sharing, isn't it? Fair sharing. 1 for you, 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 1 for you. What's the answer? How many in each sack? It's 3. 9 divided by 3 equals 3. 1, 2, 3 in there, 1, 2, 3 in there, 1, 2, 3 in there. So if you have 9 footballs and you shared them into 3 bags, there would be 3 footballs in each bag. Let's move on to the year 4 level work. Put the footballs back. And we'll be on question 6 next. Question 6, the value of the 5 in 3,895. The value of the 5 in 3,895. Well, it's just in the units column, isn't it? Units, tens, hundreds, thousands. But it's in the units column, 5 units. Or you could say 5 ones, because ones are units. As a digit, just 5. So that was question 6. We'll just put the question numbers on. Question 6, and we're on to question 7. Question 7 is plus 4583, 4,583, plus 3,916. 3,916. This is a plus. 3 plus 9 is 6. No, 3 plus 6 is 9. 8 plus 1 is 9 as well. 5 plus 9 is 14. 4 plus 3 is 7, plus 1 is 8. 8,499. Plus makes things bigger. So this number that we started with, when we added something to it, it got bigger, didn't it? 8,499. Another little check I often do is just check my units column. Is 3 plus 6 9? Yes, it is. It's just another quick check I do sometimes. And it's time we moved on to question 8. Now this you might remember from a previous morning maths, where we used some dates. 2020, or in years 2020, take away 1,896, or in years 1896. I don't know if you remember what happened in 1896 from our Olympic morning maths day. It was actually the start of the modern Olympics. So if you do 2020, take away 1896, you'll see how long ago the modern Olympics started. As long as you're watching this video in 2020, when I'm making it. So, 0 take away 6 we can't do. Borrow from the 2. 10 take away 6 we can do, that is 4. And 1 take away 9 we can't do. We would borrow from the 0, but there's nothing here, so we need to go all the way to the 2. Goes down to a 1, 1 comes here. 10. Goes down to a 9, 1 comes here. 11 take away 9 is 2. 9 take away 8 is 1. 1 take away 1 is nothing. So 124. It was 124 years ago when the modern Olympics started. So if you need to ever find out how long ago something was, you get the year you're in now, and I'm making this in 2020, and you take away the year that other thing happened in, and you'll see how long ago it was. Let's move on to question 9. Question 9 is 11 times 4. Pretty easy, just times tables for year 4. 11 times 4, 11, 22, 33 and 44. The answer is 44, isn't it? But I just wanted to do it with pictures because you're coming into your multiplication topic. So it's like, how many players in a football team? 11, you probably know. But what if you had 4 football teams? 11 times 4. Well, here are 4 football teams. How many people would you have if you had 4 football teams? You could count all the people and it would be 44. 11, 22, 33, 44. That's what times is. So you've got a football team of 11 players. You've got it 4 times. You're going to have 44 players. That's what times is. It's when you've got the same thing, and the thing in this case is a football team of 11. You've got the same thing 4 times. That's when you're going to use times. That's the kind of word problems you're going to use times for. I know not every player is the same. Like this player is not the same as this player, but it's still 4 teams of 11 players. So 11 players is still a football team. So the kind of word problem you get is there are 11 players on a football team. How many players would there be on 4 football teams? You do 11 times 4 and it's 44. Thanks to those players. And we'll move on to question 10. This we're going to use a method for. 789 divided by 3. I could get 789 footballs and share them out between 3, but that would take a long time, wouldn't it? And it would take a long time for me to make 789 of these little footballs. So we use a method instead because that would take so long. Instead we see how many 3s will fit into this 7, which is actually in the hundreds column. How many 3s fit into 700? It's a lot. Well, you can pretend it's 7 for the sake of this method. So how many 3s in 7? 3, 6. I can count 2 before I go too far. I only counted up to 6. This is 7, so there's 1 remaining. So how many 3s were in 700 was actually 200, but we carried over 100 that was still left. Now we're saying how many 3s in 18, which is really 18 tens, 180. But anyway, how many 3s in 18? 3, 6, 9, 12 and 15. 18. I counted on my fingers and it was 6. Which is, as this is the tens column, of course. Tens. What I really just did is how many 3s in 180, and it was 6t, wasn't it? How many 3s in 180? 60. Now we come to the units column, how many 3s in 9? 3, 6, 9. My finger said 3. Our answer is 263. So we don't normally talk about hundreds, tens and units when we're doing the bus stop. But that's what we're actually doing. We're seeing how many 3s fit into 700s, how many 3s fit into 18 tens, how many 3s fit into 9 units. And we're finding our answer of 263. This is a really short way of sharing out 789 footballs between 3, which would take ages. Time for the year 4 level work, year 5 level work. Question 11. Value of the 7 in 2.357. 2.357. I always line up the dot. Units is before the dot. Tenths. Some teachers write a little t, don't they? Hundredths. Some teachers write a little h. And thousandths. Some teachers write a little th. Different ways of doing the hats. You might see as you go through your school life. So 2.357, they want the 7. That's this one. That's 7 in the thousandths column. 7 thousandths. Thousandths. That's what it is. So have that sound on the end. As a fraction, 7 over 1,000, because it's in the 1 thousandths column. 7 thousandths. You could write that as a decimal as well, couldn't you? Line up the point. 0.007. That's what that thousandths is. Well, I've given 3 answers today for this question. They're all worth the same. 7 thousandths is the answer, or 7 over 1,000 as a fraction. So 7 thousandths in words. 7 over 1,000 if you write the fraction, and 0.007 if you write the decimal. They're all correct. Just look different. Let's go on to question 12. This is the kind of thing you might do in a shop. Add. Now don't get confused by this comma. This is not a comma within a number this time. It's not a comma within a number. It's a comma to separate these 3 different prices of $2.99, $4.99 and $7.99. Because you wouldn't get a decimal point with a comma after it in a number. That can't happen. You can get a comma before the decimal point. You can't get a comma after the decimal point. So we get $2.99, $4.99 and $7.99. You know, in shops lots of things have these kind of prices. $2.99, $4.99, $7.99. I'll do a quick estimate first. This is nearly 3, this is nearly 5, and this is nearly 8. 3 plus 5 plus 8 is 16. So I think this should be something like 16, but probably a bit less, because each one is 1p less than the pound when I did my estimate. So let's add these up. 9, 18, 27, that's 27. 9, 18, 27 plus 2 is 29. 2 plus 4 is 6, plus 7 is 13, plus 2 is 15. 15.97. I thought it should be about £16, and 15.97 is definitely about £16. So I'm happy with that. £15.97. If it's money, it didn't even say it was money in the question, but it does look like money, doesn't it? 15.97. Let's go on to question 13. 7 reduced by 5.21. What's the biggest number? 7 or 5.21? Because the biggest number's going on the top. 7 or 5 and a bit. 7 is bigger than 5 and a bit. 7 is bigger than 5 and a bit. To make this work with a minus 7, we need to make 7 point nothing. That'll make it work. 0 take away 1 we can't do. Get some help from the 7. Goes down to a 6, get the 1. Goes down to a 9, get the 1. 10 take away 1 is 9. 9 take away 2 is 7. Do not forget the decimal point. 6 take away 5 is 1. 1.79. So it was 7. We took off 5 and a bit, and we ended up with 1 and a bit. Because minus makes things smaller. Question 14 next. 4 lots of 449. Lots of means times. 4 lots of 449. I'm going to put the most digits on the top. 449. I'm not lining it up correctly because times, you don't really line things up correctly. I have to put the 4 over here. You line it up down the right when you do times, don't you? Even when it's got decimals in, which you wouldn't do with any other sign. So let's do 4 times 9. 9, 18, 27, 36. That's 36. 4 times 4 is 16. Plus 3 is 19. 4 times 4 is 16. Plus 1 is 17. Is it 1,796? Is that right? 1,796. Say yes or no. 1,796. Hopefully said no, because I hadn't put my decimal point in. 2 decimal places in the question, so 2 decimal places in the answer. It's 17.96. Make sure you don't forget that decimal point. And we're on to question 15. 19 divided by 8. 19 divided by 8. Now you can divide anything by 8 if you're happy to get a decimal answer. 19 point nothing. Or 19 point nothing nothing. Still the same as 19. I normally put 2 places on. But when you divide something by 8, you often need 3 places. I'll see what happens. Maybe I need 2, maybe I need 3. So, how many 8s? Let's line up this point before we even start. Because on division, the point does line up. How many 8s in 1? Definitely 0, because 8's far too big to fit into 1. Carried a 1. So we didn't use it. How many 8s in 19? 8 and 16 is 2. I sing up to 16, that says 19. So 17, 18, 19, that's remainder 3. Just count the remainders in 1s on my fingers. How many 8s in 30? 8 and 16, 24 and 32, that's too many. We can't go past 30, can we? 8 and 16, 24, so that's 3. But I only counted up to 24, didn't I? And that says 30. So I've got to count up in 1s from 24 up to 30. So I go 25, 26, 27, 28, 29, 30. And I count 6. Does 8 fit into 60? It doesn't, because 60 is not in the 8 times table. Which means I'm going to need another 0 in a minute. Anyway, how many 8s in 60? 8 and 16, 24 and 32, 40, 48 and 56. That's all I'll get. My fingers say that is 7. But I'm saying to 56, that says 60. So I'll count up in 1s, 57, 58, 59, 60, and it's remainder 4. I'm going to place another 0. 8 will fit into 40 because it goes 8 and 16, 24 and 32, 40. 5. 2.375 is our answer. We don't really need this 0 at the front. 2.375. So 19 divided by 8 is 2.375. And we're on year 6 level, question 16. Let's go nice and fast. So value of the 9 in 79.77. 79.77. Line up the point. Units is before the point. And that's the one they want, isn't it? They just want the units. So 9 units. Could put the other hats on, but we straight away got the one we wanted. 9 units is just worth 9. Quite easy as long as you're careful. Decimals are there just to try and trick you. And we're on question 17. I'm going to put what looks like the biggest number on the top, and it is the biggest number, 37.486. In plus, it doesn't matter what number's on the top, but a lot of people do like to put the biggest one on the top. Line up the points. Always line up the points in a line going down like that. Otherwise, your plus won't work. And we've got 8.65 to add on. 37.486, 8.65. So it lines up like this. Make sure you get your lining up right. Then I'll do the add-in. And we get 46.136. Plus makes things bigger. So 37 and a bit plus 8 and a bit is 46 and a bit. Looks right to me. We're going on to question 18. It's a takeaway. What number goes on the top in a takeaway? The biggest. So is it 2.2 or 8.19? It's 8.19. That's the biggest. Let's get the points in first, and we can see that 2.2 goes here. So this time it was actually the second number in the question that was the biggest rather than the first. That's what happens when you get this something less than 8.19. It means you start with 8.19 and you've got 2.2 less than that. So be careful which one goes on the top in that question. I'm going to place this little extra 0, which doesn't change the 2.2, because 2.20 is still 2.2, but it just looks nice. 9 take away 0 is 9. 1 take away 2 we can't do. Get some help from the 8, goes down to a 7, get the 1. 11 take away 2 is 9. 7 take away 2 is 5. 8 and a bit take away 2 and a bit was 5 and a bit. 5.99. Minus makes things smaller, doesn't it? Let's move on to question 19. Long multiplication, I would say here. 347 times that by 49. On these long multiplications, you need 2 lines and you add them up at the end. You place this 0 here so we can pretend this 40 is 4 when we get to it. Top line I'll do in claret. 9 times 7 is 63. There's 9s and 7s in this, so we've got to be careful of our times tables. 9 times 4, 9, 18, 27, 36, that's 36. Plus 6 is 39. 9 times 3 is 27, plus 3 is 30. So what I've done there is I multiplied 347 by 9. And it turned out to be 3,093. Take away my little ones. I'm going to cross out the 9, because that really helps me focus on what I'm doing next, which is 347 times 4. But obviously, being the tens column, it's really 40. It's really 347 times 40. But if I put the 0 in, I can pretend it's 4. 347 times 4. So 4 times 7 is 28. 4 times 4 is 16. Plus 2, 18. Always pause if I go too fast on these. And just catch up and then carry on. 4 times 3 is 12, plus 1 is 13. Cross out the little ones. The second line is always bigger than the first line. Then we need to add up our 2 answers to get our final answer. 3 plus nothing, 3. 9 plus 8, 17. 0 plus 8 plus 1, 9. 3 plus 3, 6. And a 1. 16,973. That's a lot of work in there, so I'm going to check over it because I know I may well have made a mistake. 9 times 7, 63. Excuse me while I just mutter away checking this. So that was 4 times 7, 28. 4 times 4, 16 plus 2, 18. 4, 12 plus that's it. Okay. 16,973. I don't think that's right. I think there's something wrong with this. I'm going to do something I've actually never done before in here. But when I have suspicions, I tend to do things again. I'd rather keep my first workings and do it again. But I'm not going to have space. So I'm going to note down the answer I got. I'm going to do this again. And see what happens when I do it again. See if I get the same answer. So let's see what happens. 347 times 49. 347 times 49. Let's go 63. That's definitely 63, isn't it? 9 times 4, 30. Yeah, this is where I went wrong. This is where I went wrong, I think. 9 times 4. I really don't know what I did the first time, but I think I did something wrong. 9, 18, 27, 36. Probably you know what my mistake is. 36 plus, I think I know what it is. That 9 times 4 anyway is 36. Plus 6, that goes to 42, which is not what I got before. 9 times 3 is 27, plus 4 is 31. So hopefully you're sitting there knowing my mistake, and hopefully I fixed it now. Let's see what the second line comes out as when I multiply everything by 40. So 4 times 7, 28. 4 times 4, 16 plus 2 is 18. 4 times 3, 12 plus 1, 13. Let's add these up. 3, 10, 17,003 I've got this time. 17,003. So I've done it twice. I went wrong here. I think I got it right this time. 17,003. But what you don't actually know for sure if it's the second time you did it that made it go right, or if the first time was right. Because I've got two different answers, haven't I? So now if you don't have a lot of time in a test, you're not going to be able to do this. But sometimes you will have the time to do this when you're checking over. I'm going to do it one more time, and I'm going to see which answer I get. It will probably be the fastest time, but I'm going to see which one is right. 9 times 7, 63. This is where it was different. 9 times 4 is 36 plus 6 is 42. I'm sure about that now. 9 times 3 is 27 plus 4 is 31. Done that. Put the 0. Don't need those. 4 times 7, 28. 16 plus 2, 18. 12 plus 1, 13. Cross those out. Yeah, we're getting the 17,003 answer again. So I'm going to go for that one. I'm pretty sure that's right because I think I was getting something wrong. You've probably known this the whole time, some of you, watching my video. This was the bit I was getting wrong. Now I've changed it to 17,003. And this is what genuinely happens to me. You know, I'll sometimes make mistakes, but it's all about finding your mistakes. You need to be able to find them. You shouldn't, doesn't matter if you're in, how good you are at maths, it doesn't matter. You shouldn't sit there pretending you get everything right every time. You've got to check very carefully. That's the only way you'll get everything right, by checking really carefully. So that's the longest I've ever spent on this. I haven't done it 3 times, but 17,003 is my answer now that I'm putting in. So we're going to number 20. 1 divided by 3. This is not 3 divided by 1. It's not just 3. It's 1 divided by 3. Doesn't work unless you do the 0.00 thing. How many 3's fit into 1? 0. 3 is too big to fit into 1. Carry the 1. How many 3's in 10? 3, 6, 9 is 3. Carry the 1. How many 3's in 10? 3, 6, 9 is 3. Carry the 1. I'll need another 0. How many 3's in 10? 3, 6, 9 is 3. Carry the 1. How many 3's in 10? You can keep placing zeros as long as you want to make this work. Or you might know what's going to happen, some of you. Give me some more space. How many 3's in 10? As usual, 3 carry the 1. 3 carry the 1. Place another 0. How many 3's in 10? 3 carry the 1. How many 3's in 10? 3 carry the 1. It doesn't finish. It's 0.33333 forever. And it never ends. It will always be 0.3333333. But there is a short way of saying it. You can say it's 0.3 or 0.33 recurring with this little line or dot above the 3, just saying it's just going to go on forever. So as a decimal, you could write 0.33333 forever, but you've probably got other things to do with your life. So you just write it like this. The answer to this is actually, the answer to this question is actually better as a fraction. 1 divided by 3 is literally 1 divided by 3. 1/3. So 0.33 recurring is 1/3. Right, time for the answers. I feel like I worked hard today, especially on that number 19. Have a check over your answers. See how you did. Pause this because I'm about to stop it. And I'll see you again next time.